necessarily ones you can use.
No. It's just a little busy.
Just makes it a little better. Just a box.
No, it's mine.
That is your horizon block.
Hey, clam was used, you're just, the only time I was keeping you was just for the static drops out.
That's great. I wasn't.
Located out here on the missile range, we have the opportunity to fire high energy lasers and go against targets that are fired at us. It's a great location. We got a nice mountain backstop that allows us to do a lot of different things that many other test sites that belong to the Department of Defense can't do. For LMD, what we brought to the table for them is our experience in directed energy. We've been out here, I've been here on site for around 20 years. We've been testing out here. Health staff has been out here since the early 80s when it first started propagating out here. So we bring experience, and we bring all the assets of the range, which is the telemetry, the radar. There's many things out here that are already set up for the missile function that White Sands has, that can be or is being used for LMD that's not available at many of the other test test ranges.
The airspace available and the ground space available here at Whisper, it provides a very suitable location where you can close off all the airspace required, all the area required in order to conduct a safe operation with lasers, particularly when you're going dynamic against aerial targets where you are potentially propagating the laser at long ranges and open areas where you don't want any other aircraft being around. You need to be able to, have a reliable system to transmit data from the LMD or from any laser system to the other supporting devices such as a radar or GPS. So providing that interconnectivity is an issue sometimes, especially when you're dealing with networks. And I have been at Health Staff since 2006, so I've been here for 8 years. Started as a co-op, and then I started full-time as a test engineer in 2008. Definitely participate in the career fairs at the universities. Wismar has a very good presence at the career fairs there. That's how I got the position there. I went to the career fair. Definitely tried to take relevant courses, obviously, have the right degree field in mind, but the career fair was actually a very good source of getting that job opportunity. Well, as far as, and this goes for any customer, not just LMD, but you have to be open to any requirements that the customer may have. Nothing is off the tables unless you have absolutely exhausted all possible options. And you have to be willing to work with the customer, and sometimes you have to make concessions on both ends, but definitely you have to be open and you have to be flexible, which is one of the key things. Flexibility, especially with laser programs, is key in order to be able to support the different things at play when it comes to testing with lasers. It's not just the system itself, but the airspace and also other supporting functions that need to be available. They have to be remain flexible to all the changing requirements and the changing needs of the device and the system.
This iteration, we're doing some tracking missions, preparing for some further acquisition tests that we're doing with Health Staff and Material Test Director. LMD is, of course, it's a mobile demonstrator with high-energy lasers. We're counter-rocket, counter-mortar, counter-artillery, and then also counter-UAS right now. We've tested all that here with our last couple operational tests at Health Staff and White Sands. Yeah, this is an Army S&T program, Science and Technology program right now. It is a demonstrator. It's not a fieldable system yet, but it is truly just a test article right now for the follow-on to potentially a program of record. Yeah, the Army has committed itself to solid-state lasers, and now that we're away from the chemical lasers, so solid-state lasers are the future, electric lasers, and we are doing that for the Army now and proofing that out. Solid state is using strictly electric energy, okay, and then the chemical was used to, as it states, a chemical mixture that produces light, and that has been basically phased out to some degree now. It's Army, logistically, it just wasn't viable anymore. Clean energy, more efficient energy. The electronics are a little more state-of-the-art, and it lends itself to reliability for the Army. Yeah, that was actually one of the first proof of principles for lasers out here. White Sands Health Staff and Material Test Directorate with Flight Safety did a phenomenal job on our operational requirements that we did. The distances we typically worked were about anywhere from 8 kilometers into about 2 kilometers. Worked very well. It was a Class 2 surrogate UAS. And we had a shoot down with that, and multiple tracking missions as well. We also did some airborne target lasing to check our aim spots, or aim points, and we did about 9 operations out here on that. Good question. It's basically with the counter-ISR is the biggest threat right now, so that we did do some counter-ISR threats, and we actually worked that very well. We actually killed some ISR systems with the laser program here with LMD, and that was at extended ranges, that was with the 10 kilowatt laser. The Army is supporting the effort that our next acquisition will be a 50 kilowatt laser. It will be still counter-mortar rockets, artillery, and UAS. So this beam director on LMD will still suffice for that kilowatt rating. And this will be the next phase, if you will, for LMD and the Army. So right now that's where we're going, is the 50 kilowatt. Correct. Everything's contained, if you will, in the box or connex, if you will, of the vehicle right now in the HEMTT vehicle. Right now this is our platform, and everything will still be there with the main optical bench, the lasers itself will be there, and utilize the same beam director.